Hi, this video is going to cover section 1, 2, and it's basically operations on real numbers is what the title of this one is. So operations on real numbers. Operations: add, subtract, multiply, divide. Real numbers are anything, fractions, decimals, negatives, positives, any kind of number that you see. So let's look at the first thing that you should really know by now, and that's adding or subtracting with, or I guess any operation with integers or negatives. So this is just a quick reminder for you of, oh my goodness, how do I add, subtract, multiply, and divide with negatives? So let's start with the rules for adding and look at those. So adding, the general rule is to, or if, I guess there's two general rules. All of a sudden I was drawing a blank here. So let's do the first rule. If they have the same sign, if same sign, add and keep the sign. Okay, the next rule would be if they have a different sign, one's negative, one's positive, or if different signs, subtract, and then keep the sign of the larger number, and keep sign of larger number. Okay, so that does not look like a number, but doesn't look like an E and R. I did not write that word so well. Anyway, so let's look at some examples of adding. So these are our two rules. If they're the same sign, keep the sign and add them. If different, subtract, keep the sign of the larger one. So if we have something like 2 plus 3. Well, they're both positive. By now, you're probably pretty good at this one. We would get positive 5. But what happens if they would have been both negative? And this could have been written with a parenthesis around the negative 3. Some books write that, some don't. But what am I going to get when I have negative 2 and I add negative 3 more? I'm going to get negative 5. So I got to add up all my negatives to get negative 5. Goodness, another example would be something like, well, what if I have 4 and I add negative 7? And again, the parenthesis could be around that negative 7, but I have 4 and I add negative 7. That means you need to subtract them because they're different signs, and then keep the sign of the larger one. So this is positive, this is negative. Subtract them, you get 3. And then what should it be, positive or negative? Well, the larger number is 7 and it's negative, so you're going to have negative 3. So you could think of it as, well, if I have negative 7, I know that's larger, and if I subtract them, I can see I still have negative 3 there. You can do these or think of them on a number line as well, right? And if you're at the first number, so like let's look at number 2 where I was at. Let's go 0, 1, 2. Here's negative 2, 1, 2. Okay, 3, 4, 5, negative 5. Just a couple dots on that. So let's look at number 2. You start with being at the first number. So I'm going to start here. So think about this as my starting place. And I want to add negative 3 or take away 3 more. 1, 2, 3. And you'd get to the negative 5. And if you think about this problem, you're going to start at 4. 1, 2, 3, 4. And you're going to add negative 7 or move negative 7. 1, 2, 3, 4, 5, 6, 7. And that would land you at the negative 3 right here. So either way, you can kind of think of it on a number line if you need to. I always tell people, you know, you face forward like you're starting at 0. Here's your little guy and he's facing forward. Smile, hair goes this way at 0. and he will move from the first number, he will move forward, or he'll turn every time he sees a negative. This is actually harder than I thought to explain this method on using this method instead of in person. But so, like for example, if you start at 2, he starts facing forward and he only turns around backward for any negative sign. So from 2, he would just move up 3 and get to that 5 mark. For this problem, number 2, he would start at -2. He starts facing this way, but the second he sees this sign, he flips around and then goes 3 this way. Anyway, my little guy only flips around. It's a little trickier when we get into the subtraction and it's double negative, and then I can show you that again. So adding, these are all the scenarios you're going to see, is opposite signs subtract, keep the sign of the larger, both the same signs kind of scenarios. Let's look at subtract. And if you're subtracting, the rule that I like to follow is change the problem to addition and follow the addition rules. So change to addition and follow your addition rules. What do I mean by that? Well, let's look. What if I have 2 and I subtract off a -3? So it's a double negative in a row. Sometimes you'll see a parenthesis around that one. Again, depends on the book. So it's a double negative in a row. Some of you go, oh, that's a positive. Great, it is. But the rule for subtraction is you can actually change the sign of the subtraction and change the sign of the second number and follow the addition rule. So this problem changes subtraction to addition, then change the sign of the next problem or next number, and this is the same problem as this. So 2 plus 3 is still 5. Double negative makes a positive, however you want to think of that. Another problem, maybe I have -7 and I want to subtract off 3 more. This problem really confuses a lot of people. It's most commonly messed up in the more advanced problems. -7 and I minus 3 more. I'm going more into the negatives. If you could think of that without this switching, that's fine. But let's think about what our rule says. It says change this sign to a positive.
Hello,
this video is going to be on the sections 1, 3, and 1, 4. I'm going to combine those really together. So let's start with 1, 3.
So you add them and
the basic idea of 1, 3 is going to
orders
be
of
operation.
10.
So let's go over what orders of operation are. Right? So another scenario you might see. This is your basic rules
You might see
for
like
any problem that
10
doesn't have an equal
minus,
sign in it.
a negative
how you
2.
simplify things.
So
What do you
similar
do
to
the
the first
first?
problem I did,
all
but
those
negative
kind of
10
things.
minus a
One
negative
thing
2.
you want to remember about
So
orders
you
of
have to
operation,
change
it
the
could be
sign
in the
of the
middle of a
subtraction and
problem
change
with
the
an
sign of
equal
the other
sign,
one, but
or the double
you have to
negative
be
becomes a
careful
positive.
of
So
the
this
order
is
in
the
which you do
same
things. So
as
everything's,
this problem.
you know, got a process.
Negative
So let's
10
see, the
plus
first step
2.
you always want
So
to do is
they're opposite
parentheses.
signs. So subtract, that give us 8. And then keep the sign of the larger
you might have
number.
learned, like,
the larger
please
number
excuse
was
my
10,
dear Aunt
so it's
Sally, or
negative
something
8.
like PEMDAS.
And why am I going over
Except
this?
I get a little
this
hesitant
is what
to
most
teach those
people
because
mess
you
up
have
in
to
the
be
harder
careful of
problems,
the
and
last couple
therefore
steps, and I'll show you
throws
why.
you off for the
I
whole
want to
semester.
grow
So
this
if you remind
parentheses
yourself
up into
again
including
before we
grouping
get into the more
symbols.
advanced problems. How do I add, subtract with negatives? How do I multiply, divide? And all those kind of
And
things.
the reason
then
why
you'll be
is
better off
because
for the
now
whole
we're going to
entire
have
semester.
square roots greater
let's
than,
see.
or not greater than,
Multiplication
absolute
and
value,
division.
exponents.
So you
We're
got to
gonna have
remember
all
for
sorts of things in this
multiplication and division
parenthesis.
both.
The next thing you're going to do is
That if they're the
exponents.
same sign, be careful of your negatives and your exponents.
If they're both
and then
negative,
the next thing we're going to want to do is multiply and
then it's going to
divide
be a positive
from left to right. So same sign, the answer
Or
divide
positive.
from left to right. Okay, different signs, the answer is negative. And the last step is add or subtract from left to right. Oops, negative. Okay,
And
so
this is
sign,
where the
answer is
please
positive,
excuse
different
my
sign,
dear
answer
Aunt
is negative.
Sally.
So I'm
The
running
problem
out
I
of
have with
paper,
that
but I'm
is
gonna
you
try to
can
finish these
multiply
problems.
or
Well,
divide.
let's look.
It's
So if
what
I
you
have
see
3 times,
first. You can
negative
add
4, are they
or
the same
subtract,
signs or are they different?
depending
They're
on
different.
what you see
So
first.
one's
So I
negative,
think it's
one's
misleading
positive,
to
so
have
our answer would be
PEMDAS on
negative
there,
12.
and I
Had
want to make
those
sure
been
the
I
same
didn't ever
sign,
make
like
this full
negative
screen.
3
That's all right.
times a negative 4.
What do you do? I want to make
then
sure
we
that
would have
you
had,
positive 12. So
go
double, they're both
multiply
negative,
or
it's
divide
gonna
or
be
add or
positive.
subtract.
let's
So
look
just
at
be
those
careful of
for,
using PEMDAS and thinking through that
division.
with those
We typically
last
write
two
division
steps.
as a fraction.
Let's look
So
at
if I
some
have negative
examples.
10 divided by negative 5. What am I really saying? It's a negative divided by negative, so it's a positive.
All right,
so 10
my
divided by 5
example
is 2,
one would
and it
be,
would be
all right, what if I have
positive
24
because they're
divided
both
by
negative.
3
Okay,
times
so be
2
careful of that. If you
plus
put your
3?
answer in, even
What
if
would
it's
I
a
do
reduced
first? So this
fraction as a
doesn't have an
negative
equal
over
sign,
negative, my
so I'm
math
just
lab will count you
simplifying
wrong.
it.
You have to
What do I do
convert
first?
those.
No parentheses,
If
no exponents.
they would have been
So we're going to multiply or divide what we
any
see
other
first from
the
left to
opposite,
right.
so
we
try
see the
20
division
divided
first.
by negative
Do that
2.
first. So
I could have
24
written it
divided by
this way
3
or as a fraction,
is
but
going to
you do
give us
typically see
8.
them as a
Then we
fraction.
still have our
One's
times
positive,
2
one's
plus
negative,
3.
so it's going to be a
the next
negative
thing we do
answer,
now is the next
and 20
multiplication
divided by
or division that we see, which is 8
2
times 2.
is negative 10.
So we'd have 16
So just
plus
a quick
3,
reminder,
which would give us a
multiplication
result
division,
of
that's not what most people mess
19.
up.
So you have to be careful
The rest
from
of this
left to right.
section
What do I
am going
see
to
first?
let you do on your own. They do talk about fractions.
Oh, I like this one because it has
and
exponents
I really
in
feel
it.
like by now you probably know fractions. So the rest of it's just a review on fractions that you should be able to do on your
fraction
own.
bar.
All right, and this was all over
6
section 1
times square root of 4 minus 4.
Okay, so when you have a fraction bar, that is a grouping symbol. So you have to do the top and then do the bottom and then simplify that fraction. So on the top, let's do that first. What do we do first? Well, we have these parentheses, but there's just a specific number in there. There isn't like a 2 minus 4. There's not an operation to do. When it's just the number, it's typically just so that you realize they're times or because it's negative or something else. So we really don't have parentheses that we actually need to simplify. We do, however, have step 2, which is exponents. When I take negative 2 to the third, the negative 2 is in the parentheses, so it's negative 2 times negative 2 times negative 2, which would give us a negative 8. So it's a third power, so you can get a negative. Remember, if it's an even, it's going to be a positive answer. Okay, so our first step, we still have 5 plus, but this number here in the parenthesis will simplify to a negative 8. And then you still have the 2. Okay, I'm not simplifying the bottom yet. We'll get there in a minute. So then on the top here, what do you do next? Well, what does this mean when they're next to each other? It means times when two parentheses are next to each other. So we would have 5 plus, we have to times before we add or subtract, so negative 8 times 2 is negative 16. So we have 5 plus, okay, that's just on the top, negative 16, which would give us a negative 11. So we've simplified the top all the way down to negative 11. Now let's look at the bottom. We don't have parentheses, but we do have a grouping symbol, and that's the square root. We need to take care of that first. So we're going to do the square root of 4, which is 2. So we'd have 6 times 2 minus 4 times 6. Now we have no exponents, no parentheses. So we have to do multiplication or division from left to right. So we see this one first. So that would give us 12 minus 4 times 6. The next step would be the next multiplication, so that's 4 times 6. So that would give us 12 minus 4 times 6 is 24, which is going to give us negative 12. So I have negative 11 over negative 12. Yay, I'm almost done. Now can I simplify that fraction? Well, a negative over a negative simplifies to a positive 11 twelfths. But there, you can't simplify 11 over 12. No number divides into both of those, so you're actually done here. Be careful, a couple just basic things I want to remind you of. When you take the square root of a negative number, like negative 36, remember you can't do the square root of a negative. The whole idea of a square root is what squared equals this number. It undoes a square. Square means to multiply by itself. Square root means to undo that process. So this looks like it could be negative 6, but it's not. It's 6i, which is imaginary. So in some cases you would say not possible. In some cases you would include the I, but in this class eventually we'll include the I. So I'll tell you now, it's imaginary. It's not possible, but eventually we'll use this I to represent that fact that it's not possible. Had I written that this way, that's a different problem. I'm saying, okay, the negative's outside. What is the square root of 36? Well, the square root of 36 is 6, so this one would give you negative 6. Also note if you have something like the square root of 49 over 100. Well, you can actually break that up into the square root of 49 over the square root of 100 so that you can get 7/10 pretty easily. So you can break up a square root. So you could do the same idea with the square. If you had a fraction squared, you can square the top and square the bottom separately. Right? So that's 1/3. I'm going to go ahead and add 1/4 on this video, just because it's not a super long section either, and this should all be review. So 1/4 covers the property ideas. What are properties? Properties are just the rules. How do the rules work? The biggest one I want you to cover or come out of this one is distributive property. Not necessarily knowing the word, but definitely knowing how to do it. So the first property is distributive. Okay, distributive property says if you have a number outside of a parenthesis, you can actually simplify this by multiplying the outside number by both so that it would give you a times b plus a times c. So you can get rid of the parenthesis by distributing the number outside of the parenthesis to both numbers inside. Okay, so that's the general rule for distributive. What if I have the inverse property? This one's usually the inverse property of addition. I don't have the words addition on my notes, but the inverse property, if I take, oh, that's why I have both properties right here. If I have a number like a and I add to it its additive inverse, I'm going to get 0. This is the inverse property of addition. If I have 2 and I add to it -2, I get 0. If I have -7 and I add 7, I get 0. These are the inverse property. For multiplication and division, you would times it by the inverse or the flipped over version of it. So a times 1 over a would give you 1, or 2 times 1/2 would give you 1. If you have 3, you could times it by 1/3 and get 1. So this one's the inverse property of multiplication and addition. So then let's look at the identity property. So identity, well, if you think about your identity, you want to keep your identity, right? So I want to keep my identity. I want to be Charity McKenzie. So if I want to keep that identity, what can I add to me that would still give me me? So think of a number. If I want 2 and I want to stay 2, what can I add to it to get 2? I can add 0. Okay, so the identity of addition is going to be adding 0. I get out what I started with. Now, the identity idea for multiplication, what can I times a by to still have a when I'm done? It would be 1, right? So a times 1 would give you a. So identity, you're getting back out what you started with. Whether it's an a or a 2 or 5, a 6, those are the two identity. So commutative property says order doesn't matter. Now this property again is addition and multiplication. You'll see that with most properties. Add, subtract are super picky. You have to do everything in order. It doesn't have a lot of properties that work. So the way this one works, whether it's addition or multiplication, we say, well, if we add a plus b plus c, that's the same as switching the order, maybe c plus a plus b. So anything, if I go in order on this side, I can mix it up over here. It doesn't matter for addition. They're going to give you the same results. Think of it this way. 2 plus 3 gives you 6, but 3 plus 2 also gives you 6. So order doesn't matter for addition. And the same idea for multiplication. If I take C times A, it's the same as A times C. Or think in terms of numbers instead of letters. 2 times 3 is 6. 6 times 3, or 2 times 3 is 6. 3 times 2 is 6 as well. So I can switch the order. So everything has to do with order on commutative. So associative, oops, I spelled that without all of it. Associative property, say parentheses don't matter. So sometimes they try to like mix you up like up here and they add parentheses, but you need to look. If the order switches from one side to the next, it's commutative. Associative just switches the parentheses. So for example, I did not switch the order of my letters or numbers, whatever I'm given. I always do my examples with letters because you should be able to follow letters now. And then the numbers, you can apply the numbers, any number you want. So A plus B, if I do those first and then add C, I would get the same result as if I added B and C, then added A. But notice A, B, C, A, B, C. Numbers are in the same order, different numbers in or different letters in my parentheses. So what did I really change? I changed where my parentheses were, not the order of my numbers. And this works for multiplication too. So A times B times C, A times B times C. I could do the same idea. Okay, AB, I could multiply in different orders. So think about if you're adding three numbers, 1 plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. I did it in one order. I could also go 3 plus 2 is 5 plus 1 is 6. So I could multiply them in different orders and start with different ones. And that's kind of what the associative property lets me do. The last property is the multiplication property of 0. What does multiplying by 0 do? It gives you 0. So that's just got its own property. Anything times 0 gives you 0. So that's what we'll see there. I do want to give a couple just examples of some more distributive property. So my first example, what if I have 3x minus 3, or one example, 3x minus 3, put parenthesis around that. I'm writing the answer, minus 4, it's not very helpful, 2x plus 6. Okay, so here is a little bit more complicated problem. Well, not super complicated, but it mixes in your distributive property with adding like terms and some other things that you need to remember. So first of all, we can't add or subtract what's in the parentheses because I can't add an x to a number. They have to both have the x to be able to add them. So we can distribute the 3 and simplify it that way. 3 times x is going to give me 3x. 3 times 3 gives me 9. Bring down this, well, I don't want to bring down the negative. I want you to think about this. Think of this as negative 4 times by 2x. So negative 4 times 2 is negative 8x. Negative 4 times a positive 6 would give you a negative 24. Then from here, add your terms that both have the x's in them or subtract them, and same with the numbers by themselves. So these both have the same like term of x. So 3 minus 8 would give you negative 5 of them, of the x's. Negative 9 minus 24 more would give you negative 33, and this is your final answer here. You can't actually combine an x and a number because they're not like terms. So I wanted to show you one distributive property, but 4 you're going to be going through these different properties, picking which one's which, and doing some simplification. And that is all of chapter 1.